So good day everyone, and today we'll be having the next chapter, which is the chapter 10. And the chapter 10 is talk about the nano world. So for us, we are all familiar that the nano is a small and tiny one. So the term nano comes from the Greek word nanos, meaning dwarf. It refers to extremely small scales, typically a billionth of a meter, or the 19 to the power of negative 9 meter. So the nano world refers to the structure and phenomena on the nanoscale. Exploring these worlds offers fascinating possibilities in various field perspective. So for example of this nano world, it's the human hair, appropriately 80,000 to 100,000 nanometers thick. And the next example, another example of nano world, the DNA strand, around 2.5 nanometers in diameter. The nano world involves structures and processes occurring at this minuscule scale. For this slide, let's ask why nano. So the nanoscale is significant because the nano world represents a frontier of innovations because materials and systems behave very differently at the nanoscale. The benefits of working at this scale stem from the unique characteristics that arise when the dimensions shrink to the order of nanometers. So here's the expounded answer of why nano is significant. At the nanoscale, the ratio of the surface area to the volume becomes extremely large, and the quantum effects start dominating, resulting in the enhanced strength and improved conductivity. So, matter exhibits unique properties as these scales. Example, increased strength, lighter weight, and better electrical or thermal conductivity. So this behavior is due to quantum effect and increased surface due to the volume of ratio. And now, let's talk about the brief history of the nanotechnology. So in 1959, Richard P. Feynman introduced the idea of the manipulating individual atoms in his thought. There is plenty of room at the bottom. It talks about the Richard Feynman in 1959. And in 1974, the term nanotechnology was first used by the Norio Taniguchi. So Taniguchi was the first user of the nanotechnology, everyone. So in 1981, the invention of the scanning tunneling microscope allowed scientists to observe and manipulate atoms and molecules. So in 1981 was the invention of the tunneling microscope, I guess. And next, the 1985 discovery of the fluorous carbon structures as the nanoscale sparked interest in nanomaterials. So that's the brief history of the nanotechnology. This time, let's understand the nanoscale. The nanoscale refers to the size of measured in nanometers or nm, where 1 nanometers is 1 billionth of a meter, or 10 to the power of negative 9 meters. Objects at this scale are too small to be seen with the naked eye. So we all know that the nano scale, it's a small, really small to be seen. And for context, a single human hair is about, again, 80,000 to 100,000 nanometers wide. This demonstrates how tiny nanoscale materials are when compared to familiar objects. For example, the DNA molecules. The DNA molecules that's too small, which is around 2.5 nanometer in diameter. And another one, which is the viruses. So we know the viruses also, guys, it's so typically range from 2 to 300 nanometer. And last example I prepared is the cell membranes, about 7 to 10 nanometer thick. So nanoscale, as we all know, that it should be really small, a tiny one. What is nanotechnology? The term nanotechnology comes from the Greek word nanos, meaning dwarf, combined with the technology. It involves creating and utilizing materials at scales from 1 to 100 nanometers. At this scale, materials exhibit unique physical, chemical, and biological properties, such as increased strength, lighter weight, enhanced reactivity, or altered electrical conductivity. So for examples, the medicine. In nanotechnology in medicine, its nanoparts can deliver drugs directly to cancer cells, minimizing side effects. So I will provide a video clip about this one to elaborate more the nanotechnology in medicine and to expand your knowledge about this. The nanotechnology in electronics, a technology that uses the spin of electrons to create faster, more efficient memory and data storage. For example of this is the spintronic devices in MRAM, which is the magnetoresistive RAM, are more durable and power efficient than conventional RAM. Nanotechnology in energy. The nanomaterials are used to enhance the energy density and charge or discharge speed of spacers. So the nanotechnology improves the efficiency of materials that convert heat to electricity. For example, the bismuth-telluride nanostructures are used in thermoelectric generators for waste heat recovery.
Nanotechnology is also being used in fabrics to create next-generation waterproof clothing. Scholler Technologies is using a treatment called nanosphere to coat fabrics with nanoparticles, making them not only waterproof but also dirt and dust proof. Now that's a breakthrough I can get on board with. Another great example of nanotechnology being used in our lives is the food industry. Genetically modified seeds produce more and better quality crops with increased nutrients. Genetically modified crops also don't need pesticides, so they end up reducing the cost of food to start with. Nanotechnology is also being used in the meat industry to mark meat with fluorescent nanoparticles that can indicate the presence of certain pathogens and bacteria. While nanotechnology has seemingly endless possibilities, it also has a few drawbacks and disadvantages that need to be carefully assessed. For instance, on one hand, genetically modified seeds have the solution to end global hunger and malnutrition, but on the other hand, there are also adverse health effects of some genetically modified food crops. Companies that excel in GMO food crops have been sued for potentially harmful effects on humans.
And this is the conclusion of the report of Ms. Mallory Salas. So in this part, I will report the types of microscopes. Nanoscience and technology require tools capable of observing the smallest structures such as atoms, molecules, and nanoparticles. These microscopes allow scientists to visualize and manipulate materials in a scale smaller than what ordinary microscopes can achieve. This is electron microscope. So how electron microscope works? An electron microscope uses a beam of accelerated electrons to create an image of the sample, offering magnification much greater than a traditional light microscope. So who invented the electronic microscope? It is invented in 1930 by Andreas Roska and Max Nall. It revolutionized how we study cells, viruses, and materials at extremely small scales. If we will apply the electron microscope in technology and in medical research, used to study viruses, bacteria, and human cell structures in detail, aiding and assess diagnosis and drug development. the second microscope is atomic force microscope or AFM. So how AFM works, or atomic force microscope? It measures the surface topography by feeling the surface with a tiny tip. It can take features smaller than a nanometer, a billionth of a meter. Who invented the atomic force microscope or AFM? It invented in 1986 by Gerd Binig, Calvin Quaid, and Preston Gerber. So the AFM or atomic force microscope, if it is application in technology, it is in nanomedicine, helps in designing nanoparticles for targeted drug delivery systems, examples, cancer treatments, and in biotechnology, studies DNA and proteins for applications in genetics and research. And the last one is the scanning tunneling microscope or STM. So how STM works? It is a powerful tool that allows the scientists to see and manipulate individual atoms by measuring the flow of electrons or tunneling current between the microscope tip and the surface. So who invented the scanning tunneling microscope or STM? It is invented in 1981 by Gerd Binig and Henrik Roer. They received the Nobel Prize of the breakthrough. So, in application of technology, the STM is a molecular machine assessed and the development of nanobots that can one day repair cells or deliver a drug inside the human body. And advanced in materials aids in studying the atomic structures of superconductors and advanced materials of energy efficiency. For example, solar panels.
So in conclusion, nanotechnology has already begun transforming industries in various ways. So like for example, in healthcare, nanotechnology is used to develop diagnostic tools like for example, nanochips for detecting disease and treatments like nanoparticles for drug delivery. And in electronics, nanomaterials improve the performance of semiconductors, allowing for smaller, faster, and more efficient devices like smartphones and laptops. And for the energy, nanotechnology is used to enhance solar panels, making them more efficient and to develop next generation batteries and fuel cell.